The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, good evening, good afternoon, wherever you are, different parts of the world. This is Krishna Vidula from IUCE. Welcome to another exciting webinar, global webinar of IFEES, GEDC, and IUCE. Today we have MathWorks with us, and as you can see on the screen, the presenter is David Willingham, Senior Project Manager for Deep Learning. Just a couple of words about David. He is a senior project manager responsible for MATLAB's deep learning toolbox. He joined MathWorks in 2006, and during this time amassed over 10 years of applied engineering experience, supporting a variety of application areas in artificial intelligence, including deep learning, machine learning, reinforcement learning, statistics, big data, cloud computing, and predictive maintenance. He has a bachelor's degree in electrical and computer systems engineering from Monash University in Australia, so in 2003. So it's over to you, David.
Okay, thanks, Krishna. And I'd like to say thanks for inviting me to speak today. It's my pleasure to present on this topic. Along with myself, there are a number of MathWorks colleagues on the line. So if anyone does have questions throughout the talk, please feel free to write them down in the chat window. We'll do our best to address those while the talk is on, and also there's some time allotted at the end if you'd like to ask your questions then. So, thanks again, and let's begin. So, hi everyone, my name's David Willingham, Senior Product Manager for Deep Learning at MathWorks, and today I'll be talking to you about teaching AI with MATLAB. What we'll do is also have, in addition to this presentation, is also have a number of polls and for you to get a chance to engage with us as well, where you'll enter some answers to some questions. So look out for those as well. And with that in mind, what we might do is start the first poll. So if you could, Krishna, let's check out the first poll. And
great, I will get your first poll in. And the first poll, it says, does your university have a data science center? Okay, and it's yes or no, okay? Or currently establishing one. So let's see if, so we'll launch that right now and get your results. So, nothing, okay, there we go. Okay, there we go. Does the university have data science center? Or an AI center, yes or no? Or currently establishing one? Okay, the responses are coming in. Just get them in soon so that we can see our results. Everybody's excited to see the results now. Okay, so we got half of you have voted. We'll wait another few seconds for the many more of you to vote. And okay, I think we have enough results to give a representation of what's happening here. So I'm going to close. I'm going to share, and it says 25% say yes, David.
Okay, great.
59% no, and 16% say they are establishing one. Okay, so go ahead.
Okay, thanks a lot for that. All right, so let's begin today's talk. So, look, the title of the talk is Teaching AI with MATLAB, but I wanted to speak to you about more than just the fact that this is about teaching AI with a piece of software. It's much more than that. It's about teaching that AI is more than just building a model. It's a workflow. It's about teaching AI plus a particular domain, aka AI plus X. It's about teaching AI with MATLAB means teaching AI with support from the makers of MATLAB, which is us at MathWorks. So this is what I really mean when I talk about the fact of teaching AI with MATLAB is it's more than just one thing. So I'll cover all of these three items, but I'll also cover a few more items that add emphasis to what I'm talking about. And first, I'll start off by talking about trends and challenges facing the industry and as well as education in adopting AI. So the current artificial intelligence megatrend has origins that date back to the dawn of computing. It's evolved to include machine learning and now onto deep learning into the 2000s. There's a lot of hype around where AI could go and the amount of value that it will add to the worldwide economy. Here's a figure by McKinsey. We talk about $13 trillion will be added in to the worldwide economy in about 10 years' time. But if we look a little bit closer to where we are now, just in the next 2 or 3 years, a lot of companies are calling out the fact that they are increasing their investment into AI projects. So from another research firm, Gartner, they went ahead and polled a number of different companies that are a part of their research pool, and they've told them, and I'm now telling you, that there's going to be about a 10-fold increase in the number of projects in just the next 3 years, which is quite staggering from where we are today. But in that same survey that Gartner presented, these same companies voiced some concerns about the adoption of AI. And they talked about these concerns as challenges, and you can see them listed there on the bar chart. And the top thing that they're concerned about is the skills of the staff. And what that means is they want to make sure that their staff has the right AI skills to take advantage of all of these transformative technologies and apply it to the businesses and the companies that they work for. And so, that's right up there near the top. Along with that is data quality. So I'll touch on data quality as well during this talk, but I'll mainly focus on how if you can teach AI within your particular engineering and scientific domains to your students, that they'll be primed to address this skills gap challenge that the companies call out. But since this survey was done, something else has happened. Gartner also released another press release just last month, and it talks about the fact that since a lot of companies have gone to a remote workforce, that even when the COVID situation does resolve itself, hopefully very soon, that they'll continue to allow employees to work from home. So there is this overall AI trend, but then there's also this other trend of being able to work remotely. If we look at the dollars that are now being invested into research in AI, it's also quite staggering. Here I've got some highlights from a report from the UK, which talks about the fact that over £1 billion, £1 billion will be invested into AI in the next 5 years. And what that equates to is about 1,000 PhDs in AI by 2023. So it gives you some basis for comparison on what dollars means to funding PhD research. Just going back to this £1 billion figure, if you're wondering what it looks like in the US, well, I did a bit of research and found a particular website called Statista.com, and they call out the fact that about $16.5 billion US was invested in AI research in just 2019. So slightly different scale, but you could probably do the math and work out how many PhDs funded that means. So the amount of investment into research is on the rise as well. So how is MathWorks positioned to help both academia and industry tackle these challenges that are facing AI adoption? Well, I'd like to say very well. We've been developing MATLAB for over 35 years and making significant investments into developing our AI capabilities for our users in engineering and science, enabling them to perform the latest research and realize that research in industry in next generation products. And it's not just our own opinion. Gartner, the analyst firm that I mentioned to you before, they also release magic quadrants for different technology areas. And these magic quadrants are produced so that people can be informed on the different players that are out there in a particular market and their level of maturity. And yeah, MathWorks, if you squint your eyes hard enough, they're in the top right corner and nominated as a leader. So we're quite proud to be there, but we didn't just get there without any effort. It's been 35 years of continuous development effort, and look, the job's not done. We're going to continue to keep going. Our software is used to design and simulate and test many of the products that you commonly know and use every day, whether it be one of the modern automotive vehicles that you're driving, hopefully one of the planes that you fly in again sometime soon, the smartphones you use, and even smart consumer goods like very intelligent washing machines that do a whole bunch of things that you never knew you needed. So our software has been used by engineers to design, simulate, and test these systems. But it doesn't just stop with common goods that we're all aware of. It's also engineers and scientists are also using our tools to develop breakthrough technologies, transforming the way we live and work. From things like reusable rockets. We've got a nice picture here of Blue Origin launching one of their reusable rockets, to autonomous robots doing some pretty cool tasks that will help us in our day-to-day lives, to advanced prosthetics, where researchers are developing next-generation prosthetics such that they give back abilities to those that have lost them, but they're not just giving back those abilities in the form that they once knew. They're actually enhancing their abilities beyond what was possible before. And also clean energy. So engineers and scientists are developing breakthroughs all the time, and it's great that MATLAB's a part of it. If we look across the board, there's a number of industries that are using our software, and look, we've called out about 15. There's probably a few more, but the main thing is that our software is used in all of these areas by engineers and scientists, both in education and industry. And what we try to do at MathWorks is learn from one industry and apply it to another. And if there's a trend that's emerging in one of these industries and we can build some technology around it and then apply it to another area, we'll do it because that's going to benefit everyone in those other industries. In fact, if we think about AI has been around a long time, but right now it's pretty much across the board in its adoption. I would argue that every single one of these industries is now looking at AI and looking to apply it. And so here's a few customer reference stories around the adoption of AI and the use of AI. So we've got some use cases here from Shell, who are using deep learning and machine learning in oil exploration and processing. We've got V&E, who are using AI for lidar object detection for autonomous vehicle development. Genentech and Ritsumeikan University are talking about medical research and medical devices, and Musashi Seismitsu looking to detect abnormalities in their manufacturing process. So, the use of AI is growing rapidly in all of those industries, and here's some great shining use cases of that technology in action. Okay, but if we look to education, how are we primed and ready to help you? Well, I mentioned to you that MATLAB's been used for over 35 years. Our first license was sold to an educational institution just up the road at MIT. And it's now grown from that one university sale to over 6,500 universities and colleges worldwide using our software and teaching with our software. About 1,000 of these schools have access to our campus-wide license. So that really means open access for all, undergraduate, postgraduate, professors, teachers, everyone. And what that is doing is it's equating to a large amount of students being taught MATLAB, a large amount of students learning MATLAB. I think it's quite staggering that this figure here, about 1 million students are going through the online courses that we provide each year, and it's resulting in thousands upon tens of thousands of graduates getting into the workforce each year. That workforce could be industry, but it also could be research. So look, MathWorks is a great presence in education, and why we're here today to speak to you. But it's not. I mentioned to you that providing software isn't all we do. We do look at partnerships as well, as this is a way in which industry, academia, and software vendors like MathWorks are able to drive and accelerate the use of transformative technologies like AI. They all feed into each other, from teaching undergraduates to providing the next generation researchers for the universities, or to graduates to industry, where research institutes are doing groundbreaking research and providing technologies that can be used by industry, and industry actually saying to academia, look, there's some great problems here to be solved. Can you help out? It all feeds into each other, and it's helping drive the acceleration and use of AI. And yeah, at the center of that is MATLAB. So the next section I'm going to be speaking to you about is teaching AI as a workflow. I think this is a good moment to pause and start another poll. Krishna, if you could.
Yep, I'm ready with the poll. Okay, so we're going to have the next poll. This is about, does your department have a data science or AI course? That's the one, right?
That's a closed one.
Yeah, we'll do that. Okay, first we do that. So let's do this one very quickly. Does your department have a data science or an artificial intelligence course? Yes, no, are currently establishing one, and we'll give you about 30 seconds. Get in there in 30 seconds. We got half of you already in there for the first 15 seconds. Let's get the rest of you in there in the next 15 seconds.
Oh, great.
Okay, great. So we have got good enough information for you to have some idea what's going on with the audience here. So I'm going to close that and I'm going to share. 53% say yes, 32% said no, and 15% said currently establishing one. Okay.
Oh, great. Thanks everyone for providing that feedback. It's very helpful. Okay, so we'll now talk about teaching AI as a workflow. Okay, so look, to successfully apply AI, it's important to think about where it's going to be used in an overall system. In other words, a successful AI implementation, it goes beyond just developing an AI model. It requires looking at how that AI model fits in an end-to-end workflow of an entire system, from data preparation to how it's fed into the AI modeling, to an overall system design for where that AI model will reside, and then ultimately deploying it into a piece of hardware for that AI to be realized in a physical thing. And MATLAB and Simulink enable engineers and scientists to work on the entire workflow, not just the modeling section. So I'd like you to think about or consider teaching the entire workflow when you're teaching AI. So it goes beyond just the model. It's about looking at all of those other components that surround it. I also mentioned that MATLAB and Simulink are open platforms. A little bit on that coming up in the talk. If we drill down on each of those particular sections of the workflow, there's actually mini workflows which some users are required to perform. And so what I'll do is go into the major sections and discuss some of these mini workflows in more detail. So starting with data preparation. Look, I know from the numerous amounts of projects that I performed over the years in my prior role of how important this section is. I'd always begin when any time a company would come to us or come to me and say, look, I'd like to apply AI, I'd say, what data do you have? And you need to make sure that you have the right data to feed into your algorithms. And along with the data, you also need a problem to solve. But we'll park that problem piece to the side. We'll focus on the data here. So we need to make sure you have the right data, and it's not just raw data. You need to have the right data, and you need to have a domain expert look at that data and prepare it and process it in a way that will be able to adequately feed into the next stage of the workflow. So you can't just rely on raw data. You have to put it in the hands of a domain expert. And here's a story to talk about this importance as you transition from some research you might be doing into applying that research, perhaps in industry or to part of your next stage of your project. We've got a nice pie graph here that was presented by Andre Karpathy. If you don't know who Andre Karpathy is, he is now the director of AI at Tesla. But during his PhD, he spent predominantly the most amount of his time was spent on the modeling and algorithms research that he was performing, and very little time on the data sets. It's quite often in research that you use a standard data set that is used by researchers and cited in a lot of papers, and so he didn't worry about that so much. However, when he was now that he's at Tesla, data is the biggest thing that he cares about. He needs to think about data pipelines, data pre-processing, make sure that the data that's being fed into the models and algorithms that are sitting in the cars is perfect and ready to be used by those cars for a lot of the fancy things that they do. So look, this is a nice story because it talks about the transition in thought about how much do you need to care about data when you move beyond the research. Okay, so nice story there. But I mentioned to you that it requires domain expertise. Like domain experts are the best ones to interpret that data and determine what features and what data sets are important for the next stage. But data preparation is time consuming. Going back to my own work, I know I spent probably 70–80% of my time on each project on data preparation, as opposed to the other steps in the modeling. So it's time consuming, and if you can automate part of the process, that would be even better. But I'll talk about this data preparation and time consuming nature of it in a bit more detail through another story. The story I have here is to do with the gentleman in the top left. His name's Peter Cork. He's a professor at the Queensland University of Technology in the field of robotics. Here is Peter about to present at our MATLAB Expo in 2016, and he's sitting next to a pretty friendly gentleman. If you don't know who this person is, it's Cleve Moeller. He's the original author of MATLAB, and happy smiling faces, that's what we like to see. But Peter talked about a number of projects that his robotics lab is doing at the moment, and one of them was to tackle a pretty important problem to the ecosystem of the Great Barrier Reef. There's a starfish called the crown of thorns starfish that is ravaging the reef, and it looks like something out of a horror show there, and they're multiplying in millions and millions of numbers, and they destroy the reef along the way. So Peter's robotics department is looking to tackle this problem and try to get rid of these starfish. The way to get rid of the starfish is to inject them with a solution of vinegar, and they'll shrivel up and die. Right now, divers have to do that, which is not scalable. So what his lab is doing is developing autonomous submarines that will go around, detect the starfish, inject them with the solution, and move on to the next one. And obviously, if this gets developed, they can build a number of these submarines and go off and do this at scale. Now, the problem that one of his PhD students was facing is that a lot of the pre-trained models for deep learning, which is what they were they were using aren't trained on crown of thorns starfish. They're a very unique, I guess, a species, and no data set's been trained on it. So his student had to spend 6 months of time labeling reef images and detecting and cropping crown of thorns starfish. So it took 6 months of a domain expert to generate enough data to feed into the next stage. And yeah, it's a problem. So, MathWorks, we're about trying to solve these time-consuming problems for engineers and scientists. So what did we do? Well, we developed apps to enable new users and domain experts and even experienced experts label their data sets a lot quicker and easier, and in many cases in an automated fashion. So we have apps for image labeling, and we've got apps, it's apps for signal labeling as well, and many more. And when I showed these apps to Peter at that same expo a few years back, he was like, wow, David, you've just shown me how I can teach something to my students and save them an enormous amount of time. In fact, I think about that one student could save about 5 months of time if he was to do that project again. And that's a lot of time he could spend on research. So yeah, MATLAB has apps that you can teach to your students so that they can generate the data sets they need. Okay, so we're going to move on to the next stage of the workflow, and that's probably the one that's the most popular. It gets the most attention. It's AI modeling. So when you're teaching AI modeling to students, you want to make sure that they have access to all of the standard algorithms for AI, from machine learning, deep learning, reinforcement learning, etc. And MATLAB has these. We have a lot of the standard algorithms available for teaching AI. But along with that, you want to allow them to have access to some of the pre-trained models that are out there at the moment. Quite common in deep learning to have a pre-trained model for image classification. So you want to make sure they have access to easily importing and using some of these existing work. But this isn't, look, I mean, this is a good start. These are the foundations. But if you want to think about one of the other points I mentioned, which was teaching AI plus domain X, you have to have examples for your students to learn to apply AI for their particular area. And you need an example that's very close to what you're teaching and what the students want to learn. And this is done through examples. So within our software, we have hundreds upon hundreds of examples of AI being applied to particular domains. In the area that I focus on, deep learning, at last count, we've got over 200, I guess, particular examples for different domains. And change of pace, what does this all look like? Well, if you want to have a look at what MATLAB looks like for applying AI, let's have a look to our online platform, MATLAB Online. So MATLAB Online is a great platform, allows you to access MATLAB through a browser, no installation required. And here you can see in about 5 lines of code, we're actually performing image classification. We're loading in one of those pre-trained models, firing up a webcam object, taking a snapshot of that webcam, a little bit of resizing, and then classify. And there you go. So very intuitive, very easy to read, and it's a great advocate. I guess this is a great advocate point of the use of our software. All right, so I mentioned that we had apps for pre-processing. We also have apps for modeling as well. Apps are great for teaching and learning. They allow you to abstract away from the coding aspect of what you're looking to apply and focus on how to build and how to explain the models that you're looking to use. So we have apps in deep learning that enable you to design new networks. So we've got a picture of our deep network designer. We have an app for managing deep learning experiments. I don't have a picture here, but there's an app for that. But what I do have is another picture of one of our apps for machine learning. And this particular app allows you to interactively import your data, try a whole bunch of different machine learning models, find the ones with the highest accuracy, look at some visualizations to help understand and explain what they're doing. And then they also can be exported as templates for reuse later on. And this is, as I mentioned, it allows you to abstract away from the coding aspect of AI and just focus on how to apply it. And it breaks down those barriers of learning that comes with having to learn to code at the same time. And here's another important point to make. I mentioned to you earlier that MATLAB is an open platform. And what that means is that you can use libraries from other languages and frameworks such as C, C++, Java, and Python. And an example of the fact that we are an open platform is with deep learning. And in deep learning, we support what's called the ONNX standard, importing and exporting to ONNX, which means that you can import and models from TensorFlow and PyTorch and export to a number of frameworks as well. So, you don't have to rely entirely on just doing everything in MATLAB as much as we'd like you to. You can look to other frameworks and languages and bring that into MATLAB and use us and MATLAB for other parts of the workflow if you want. So we're open. We're happy to work with these other languages and frameworks. Okay, so moving on to system design. What this is about is teaching students to consider the system that the AI model is going to reside in, not just the model itself. So if you take the case of an autonomous car, an AI model is going to interact with other parts of the car, also I guess smart parts of the car. So an AI model for autonomous car, its sole purpose may be just to detect objects around the vehicle. But it's got to interact with sensors for assessing distance like LiDAR and radar. It then has to make decisions based on what it sees and where they're at, and inform the control systems on the car what to do. So do I steer left or right? Do I accelerate, decelerate? Do I brake? The AI model has to interact with these control systems as well. So in order to fully understand and know what your AI model is doing, you have to simulate that AI model with interactions with all of the other components of the overall system. So I talked about a car. Here's another example of doing the same thing, but this time for a wind turbine. And here we have a model from Simulink, another one of our platforms that enables you to design and simulate physical systems. So we actually have all the inner components of that particular wind turbine there, and it allows us to simulate this wind turbine over a number of scenarios. And so, look, coming back to the data stage, if we don't have enough data, we could use this model to actually simulate some data to build an AI model. We can also use this model to inject failure scenarios so that we can get data to understand a particular problem that we want to use AI for, such as developing an AI-based predictive maintenance model. So we could use the simulation to inject failures to then go ahead and give us the data we need to build a model. And why we'll do this through simulation is that we may not have enough data, physical data of failures to work with. Perhaps they haven't occurred that much, or it's very expensive to get that data. So we can use this model of the overall system to generate data. We can train the model, and then we can actually take that model's developed and plug it back into the simulation and test it and validate it over some more scenarios to see how well it would apply to situations that hasn't faced before. We could also test it against some of the unique real-world data sets as well. So the model that you can develop with Simulink can have multiple purposes. So I'd encourage you to think about teaching students to use an overall system to train an AI model or test an AI model and simulate data for an AI model. In the last part of the workflow, I'm going to talk about deploying your model to a physical system. So look, in industry, the models are being deployed to actual pieces of hardware, and not all of these pieces of hardware are connected to the internet. So yes, being able to deploy a model to the internet's great, but having the ability to deploy your model anywhere to autonomous cars, to remote processing plants, to I guess medical devices that have privacy concerns, being able to deploy your model to anywhere is a must. And look, you can actually teach this through MATLAB, because we have the ability to automatically generate code and deploy code to embedded devices, to the cloud, and more. So, with either a line of code, a couple lines of code, or a click of a button through our coder apps, you're able to deploy code to these targets. And it's not just physical chips. We also have kits that allow you to deploy to low-cost hardware as well. So one of the kits we've got is for Raspberry Pi, and you can include low-cost hardware as part of your teaching and show how students can take a model and deploy it to Raspberry Pi. And one of the examples we ship is image classification on a Raspberry Pi, and that's a screenshot of what it looks like as a result. So, by enabling students to be able to deploy to a piece of hardware, it really summarizes exactly why use MATLAB and Simulink for teaching AI, because it allows you to teach the whole AI workflow. All right, from data prep to modeling to system design and deployment. Okay, so just a small time check here. We're going pretty well. All right, so I've got another story to tell before I move on to the next section, and it's a great story that showcases the whole workflow in action. This is around a story of digging tunnels. So here is the Ted Williams Tunnel. It's a tunnel that goes underneath Boston, and it allows you to connect from the airport to the city and beyond. And it's a great time saver. But how is this tunnel built? Well, it's built by a company called Obayashi Corporation, and they pride themselves on being able to drill tunnels very quickly. And how they do this is that they actually use the tunnel face itself and in the integrity of that tunnel to be able to drill without supports. So they drill a bit of tunnel, and they have geologists go in and assess that tunnel. And they provide metrics on the stability. But the problem is that this takes geologists hours to do, and if the operations are running 24/7, it means that there could be a shortage of geologists. And so they wanted to try and automate this process and use an AI technique of deep learning to do so. So what they did is they took the tunnel face, they broke it up into a section of sub-images, and then they had their domain experts, the geologists, label those images and produce some metrics manually. So yep, they had their domain experts label their data. From there, they then went ahead and used a pre-trained model that they had readily access to in MATLAB, and they use a technique called transfer learning, which is really just slightly modifying the pre-trained model and retraining it for their particular task. And they were able to get some pretty impressive results from this pre-trained model that they edited, and yeah, they're ready to deploy it. So they then went ahead and use one of our server-based products to enable their site engineers to have access to using this model in the field. So they had this interdisciplinary approach going on where they had geologists building the model, the domain experts are able to use MATLAB, which was great, and they now have their site engineers have access to, the knowledge that they have in producing the metrics and can build tunnels a lot quicker. So this is a great story. It really talks about that end-to-end workflow quite impressively. All right, so we're now going to move on to teaching AI plus Domain X. I think this is a good time to have a short poll break, Krishna. So if you could start the next poll.
Absolutely, yes. So you have something about a new how do you learn about a new research area? Is that what you want?
Sure, question 3, that would be great.
Yeah, okay, so I'm going to launch this one. It's how do you learn about a new research area or topic? Journals, emails, books, videos, other. So let's take 30 seconds to get your thoughts on this, okay? Keep coming. We got a bunch of people already have voted in. We're going to give you, we got half of you voted in the first 15 seconds, another half next 15 seconds, and we will be sharing this with everybody in just about 5 seconds. Okay, I'm going to close the poll and share journals 80%, emails 23%, books 36%, videos 49%, other 22%. Okay.
Oh wow, that's that seems to be a bit of I guess a rivalry between the older approach of reading journals and the new approach of looking at videos. Good to see that journals are still going strong, showing their relevance. Okay, so teaching AI plus Domain X. So what are we encouraging here? So this is about taking an existing course, and it might have been taught for years, such as audio processing or signal processing. I know I took signal processing over 20 years ago. So it's about taking one of the existing courses and looking to see where artificial intelligence could be injected into it and taught as part of that existing domain specialty for engineering or science. And so, take an existing course and look to see where you could provide a few lectures on AI theory, perhaps supplement that theory with some of our online tutorials for the students to take, and then look to apply some of the coursework assignments and projects to include AI. So that's what we mean by AI plus X, taking an existing course and see where AI fits into it. Because each of these different disciplines can benefit from AI. And we've got a few examples of this in action. So the first one is by Dr. Thomas Popham from the University of Warwick, who introduced an entirely new core module in his engineering school. And the module focuses on data science and spans all the engineering departments, including electrical, mechanical, civil, and engineering. And he broke it down into a multi-year approach where year 1, students learn through self-paced courses and guided MATLAB examples and apply them. In year 2, students then start using some of those apps I mentioned to tackle some of their problems and do project-based learning as well. And then by years 3 and 4, it's really when the students start to become more independent. So the AI is taught as part of those specialty courses that I mentioned to you before, the AI plus X courses, and so things like computer vision, it's taught there. Another example of this is from Dr. Auger Marquez, who took his existing image processing course and then looked to see where he could apply AI. So if you look at the outline there, I still remember some of these fundamentals from the image processing course that I did way back when. But what I that is particular to AI, the sections highlighted here, blue and red, the fact that he's also introducing things like deep learning, segmentation, and classification, and references it in the units as well. So AI plus X, consider that if you haven't already done so. You don't have to start from scratch. All right, so we're now going to move on to the next section on teaching AI with MathWorks support. I think we've got time for starting our next poll, Krishna,
Okay.
so we can do that.
Yeah, we'll do that. That's what tools are you using? So what tools are you using for AI? Options, Python, TensorFlow, MATLAB, C, C++, other. Okay, the numbers are coming in. Right, we got about half the people who voted. Hurry up, hurry up, hurry up, we're gonna close. We're on our time, okay? The 10 seconds. Okay, so we have some results here to share. I'll close right now and then share. Python 66%, TensorFlow 25%, MATLAB 55%, C, C+ 11%, other 9%. Got that?
Okay, yeah, thanks for that. So, look, you know, what that poll suggests is exactly what I was advocating earlier. That, you know, within AI, the use of multiple frameworks and languages is a trend. And so, you know, MATLAB is designed so that you can work with Python, you can work with TensorFlow and C, C++ and MATLAB, you know, all at the same time, and use this for the different parts of the workflow that makes sense. So that actually helps validate the what I was showing earlier. So thanks for interacting with that poll. Okay, so moving on to teaching AI with MathWorks support. So look, at MathWorks, we've got to focus on making sure that both undergraduates and graduates are benefiting from the use of AI in engineering and science. And so we're focusing on both. And when we do our focusing, we're looking at those foundational courses taught by engineering science and those plus X engineering electives that are taught by these departments. Okay, so you know, we're able to focus on these areas, and how we focus on these is through a number of means. You know, I talked about the fact that we have some online training options, so we'll point those out. We do on-campus and virtual events to help educate about some interesting topics or areas that might be useful, and even in helping develop a curriculum for particular universities that reach out and speak with us. And the people that are able to support are engineers themselves. So we have got dedicated engineers that help with all of these different options that are available, and work directly with professors and researchers in many cases. So you know, we have quite a variety of support available for education, as it's one of our primary focuses. And here's a good example to talk about that support. So KIT, Kanazawa Institute of Technology, wanted to develop a foundational course using MATLAB. They've got some nice, generous quotes on why they chose MATLAB there on the screen, but I'll focus on the collaboration. So they have about 1,500 students going through this course each year, and so they wanted to make sure that they developed the right exercises that engage the students in the right way. And so they reached out to us, and we helped them develop some of their exercises for their course, and the result was very, very well received by the students. So look, this is a great story to share there. So you know, what about some resources that you can start using from day one? Well, we have a number of free tutorials for your students to take through their browser without even having to install MATLAB, and we call these on-ramps. So we've got some on-ramps for machine learning, deep learning. We even have that for base MATLAB and a few others. Along with that, we've partnered with Coursera in providing a course on data science there as well. So you know, students can go in and do that. And look, we've got fantastic ratings. You know, almost 5, which is good to know. And along with that, we've got websites that talk about teaching deep learning and teaching machine learning with MATLAB on our website. And on that website, there's curriculum that's been developed by other universities posted there. So you can use that existing curriculum that's been listed there as a good starting point for ideas on how you'd like to apply it to your coursework that you'd like to teach. In addition to the tutorials, we also have what's called MATS, which stands for MATLAB Academic Online Training Courses. And these are multi-unit offerings that really supplement the, I guess, the full duration of you teaching a unit in one of your courses. It's got hours upon hours, days and days of unit content for students to really get a deep understanding of a particular area. And some of these that you see in the top left are dedicated to AI. All right. We're now going to move on to another part of our support, and that's in research collaboration. Okay, we'll probably have time for another poll, Krishna. So let's do another.
Which one do you want to do? The one in including AI courses? Are you interested?
Yeah, let's have a look here.
How would you include AI in your curriculum?
Yeah,
And
sure.
that
would be great. Yeah, let's do how would you do
in your curriculum?
AI?
Okay.
Yep.
I'm going to launch that. Here we go. How would you include AI in your curriculum? Use a full course on AI data science, sequence of courses, AI or data science, AI plus X, an existing course or other. Okay, so the results are coming in. Half of them have voted. The another half will come in the next 15 seconds. And we'll close in about 10 seconds. Okay, 5 seconds. Okay, I'm going to share. So this is what the results look like. 36% say a full course on AI for data science. 26% say a sequence of courses in AI data science. 30% say AI plus X. 9% say other. Okay, I'm going to hide that and you can move on.
Okay, thanks for that. Okay, so what does research collaborations look like? So I mentioned to you earlier that we partner with educational institutions along with industry. Research collaborations are a nice shining light on talking about that partnership. One of the examples here is with UMass Amherst, where they're looking to develop a novel approach for CFD modeling and simulation, which requires significant computational resources. They'd like to use AI to replace the traditional processes, and we're working with them on this. Now, I won't go into the specifics of their research. If you're interested to know more, they are publishing a paper at this at NeurIPS 2020. But instead, I'll focus on the collaboration, which is made up of 3 pillars: the software and hardware vendors, the consumers of the models, the OEMs, and also independent service providers. For our part, we're providing support in the form of our developers are engaging with the researchers to see how we can use our software for this particular unique area of AI research. But we're also funding part of the research as well. We're doing a similar collaboration between the University of Dallas, Texas, and the space agencies for deploying AI to satellites. So this is what a research collaboration looks like with MathWorks. Okay, so what I'll do is I've come to the end of the talk, and I'll finish up by summarizing what I've spoken about today. To best tackle the current trends and challenges in AI, consider teaching AI as a workflow, not just the modeling itself. There's also a trend in applying AI to specific domains or engineering and science domains, aka AI plus X. And new courses are coming out to support this. And so I consider you do the same. And for teaching AI, look, there is support and resources made available to you from MathWorks. So, and great progress is being made in research by setting up collaborations with MathWorks support. So I encourage you to engage with us if this is of interest to you. And here at MathWorks, we're continuing to help academia also through the further developing the software that we build, MATLAB and Simulink. I'd like to say thanks for listening to me today. You can learn more about all of this at mathworks.com. We've also got some emails that are going to be put in the chat window if you want to reach out directly. Thank you for listening, and we'll now open up probably for another poll and the Q&A section.
Okay, we can do that. I think put up the email. You might want to put email IDs because I think a lot of people have questions, but we won't have time for all of them today. So you might want to put up an email ID, yours and anybody else's that's appropriate. And you want me to put up some of the other polls? Would you, 3 of them say, would be interested in a follow-up discussion with AI, DL, ML in your curriculum, would be interested in hosting a discussion event for your university, would be interested in follow-up discussion for research. Which of those do you want to?
Let's start with the first one.
Okay, the curriculum. Okay, so I'm gonna. Okay, would you be interested in follow-up discussion on AI, DL, machine learning, and curriculum or research? Please select one. So let's see. Let's quickly get a sense of what the audience are looking for. So there are lots of good responses. So there seems to be a lot of need for a follow-up because we really haven't had time to discuss a lot of these things in depth, and we're running out of time soon. But I think we, as a team, I think we can work together. You guys, with the MathWorks team, I think we should kind of figure out how to follow up all this exciting interest that we've generated from this group. So I'm going to close and share. Yes, 24% said curriculum, 18% said research, and 55% said both. A small number, 3% said no. So I'm going to close that and back to you.
Okay, so I might actually ask one of my colleagues if they could post in the chat window that email address.
Yeah, could you do the email address, and Sridhar will post it to everybody. Who would like to do that? I think one of you has done it.
Okay, yep, here you go, Xinghao. She's and Julia.
So that's, Sridhar, can you pump it up to the entire audience? Okay, he got it. Okay, Sridhar sent out to the entire audience. So Jianghao at mathworks.com. She would be the one following up with all the questions. And we do have a record of all the comments and that have come in, and we'll be able to sharing that with you all, so you can respond to that. Okay, sorry, Jiang Hua said the previous one was incorrect, so she can send can share both. Okay, so
okay, yeah, so yeah, they're Jiang and Julia.
Honor, yeah, right. Okay, great.
Yeah, I guess we've got a few moments left. We could field a couple of questions. If any of the attendees want to post a question in the chat.
Let's do that. Yeah, the question, one question about recording video. We will have a recorded video of this, and will be sent out to everybody. Is this is a web-based online MathWorks license? Does it come with, or does it come with regular MATLAB license?
Yeah, so that one I can easily answer. So when you get any, I guess, a license of MATLAB, you have access to what's called MATLAB Online. So yeah, that's the web-based version of MATLAB, and it's hosted through a browser. So any of those licenses have access to that.
Okay. Can MATLAB be used to generate data related to 5G and 6G?
So I guess that's a particular one on 5G communications and 6G. I am not the expert in communications. We do have people on that. So first of all, if you have a detailed question for them, we can follow up. For 5G, yes, we actually have a toolbox that has libraries available for 5G, and that's actually been extended from 3G, 4G, LTE, and now 5G. I can't comment on 6G, but all I can say is if that's the next generation, more than likely we'll have some libraries there to support it at some stage. I just can't comment on the specifics.
Okay.
I'd encourage you to check out our toolbox for 5G to know more. I will say that on our, we have a number of deep learning examples for communications. So if you go to our website, check them out as well.
Does Raspberry Pi support MATLAB code?
So yeah, I would say we support, does Raspberry Pi support MATLAB code? So we support the ability to deploy to Raspberry Pi. So if you'd like to take models in MATLAB or Simulink and use them on Raspberry Pi, we have a dedicated kit that enable you to do that.
Okay, David, I'm working with MATLAB 6 for 6 years ago, but now I'm using Python. But looking forward to a revamped academic version for the staff. Okay, so that's just a comment, I guess.
Yeah, that's a good one, actually. It's quite often that we think of MATLAB the way we first learnt it. And what I'm here to say is that, we've got over 5,000 employees, a third of them are in product development. modern MATLAB is not the same as MATLAB from even a few years ago. There's a lot of great features and tools available. MATLAB Online is a great great platform for using MATLAB that wasn't around when I first started. So yeah, please, I encourage you to check out some of the latest updates.
I'm going to actually use our next poll of yours to get a little idea what the people are saying. Would you like to be interested in hosting a discussion event for your university? So I'm going to pull that up and launch it.
Fantastic.
So that you get some ideas, and I think we should follow up with this, folks, and see what. Yeah, I mean, they're all, everybody's interested. 97
oh wow,
98%.
The team's going to be quite busy.
So I think PJ and the team are going to be really excited about this and busy. So we need to find some mechanism, PJ and David, how to tap into this excitement of people wanting to follow up with the discussion or event at the university. I'd be able to. We're more than happy to help you that with the Indian audience, because I work with them. So that's something that we can do, particularly the competitions and such that. And so I guess that's pretty much running out of time here. So PJ, would you like to make any comments here? You can unmute yourself and make a few comments. Go ahead, PJ.
Krishna, thank you. Can you hear me? I just want to say on behalf of MathWorks, we want to thank you all for your partnership. We value it greatly, and we will work together with you on the appropriate follow-up, especially for folks that are interested in hosting something at your local campuses. So Krishna, why don't we work with you and with Hans on the follow-up? But we just want to say thank you on behalf of MathWorks.
Thank you. I mean, that's exciting. I learned a lot from this, and that's exciting. I think most of the 300 people who are here must have really gained a lot from that. David did a great job of presenting in a nice, simple manner that even I could understand. Okay, so
great.
Thank you very much, and
thank you.
And good luck to all of you. And we will keep you posted. We'll send you a list of the people who attended, and for the participants, we'll send you a recording of the YouTube recording of what we did today, and then the email of the contacts. Okay, thanks, and everybody.
Thank you.
Stay happy, stay safe. Yeah.
Stay well.
Thank you.